All right. Hey, everybody. It's Aaron again. I'm coming to you from my house here in California, and in honor of Oktoberfest, I've got my beer stein filled with water today. Um, and so I wanted to come to you, talk a little bit more about Go. I recently did my first ever remote screencast, remote talk ever at the Portland Go meetup. I actually don't know how many people were there because the camera was faced a little funny. But there was a lot of Twitter thank yous and so forth for doing this talk. So I thought I would kind of replicate it, do it again, about the same with maybe a little bit more detail, and record it and put it up on YouTube for everybody else to learn about and see. So I did the talk on Athens. I am a core maintainer on the Athens project, and there will be plenty of links out in the show notes to Athens details. But the very, very short version is basically Athens is a module proxy server for Go modules. And Go modules are new. They're as of Go 1.11, the latest release. Modules are a new dependency management system. And I'll get into that in just a second. So I'm going to go through the slides here, just as I did at the meetup talk. And I'm also going to do this exact same demo. And then I might go into a little bit more detail at the end, and we'll see how that goes. But otherwise, this will be pretty much the exact same thing as folks who went to the meetup saw as well. So let's get started. So obviously I'm Aaron, that's my Twitter. As I said, I'm a maintainer of the Athens project. I am a CDA, a Cloud Developer Advocate at Azure, and I work in the Linux containers and open source engineering team. So we do everything from proprietary Azure container stuff to Docker, to Kubernetes, to all the tooling on top of Kubernetes. And I focus a lot on Go and some other systems languages, and containerizing those things and getting them onto Kubernetes and so forth. So Athens is a big, huge part for me of the Go portion that I do. So I was a co-creator of the project, and I'm a core maintainer now, and the community is growing, and I'm super excited about everything Go modules. So yeah, that's kind of why I'm coming at you today. And I used to work in the containers product group at Azure, and I did a lot of stuff around doing managed Kubernetes on the AKS system and Azure, and some other stuff around Kubernetes and containers. So anyway, let's move past that and get into it. I mentioned Go modules really briefly just now. This is the only slide I'm going to dedicate just to Go modules. There's a link there. You can get tons more information on how things work and the technical details, etc. But basically, boiled down into two lines there. One is it's new package management that's built right into the Go tool chain. And two, a nice, awesome kind of added benefit is you don't really have to have a Go path anymore. And I love that. Just like a lot of other languages, now you can kind of put your code wherever you want on your machine and work with it wherever you want. And if you want to build it in CI, it's less difficult and so forth. So the third big thing that I take huge advantage of in this talk, and that Athens itself takes huge advantage of, is the download protocol for Go modules, for Go dependencies. And this thing is basically just an HTTP interface to download code that the Go Get tool, the Go toolchain in general, uses to get a dependency. Okay, so these are three of the, I think, 5 or 6 endpoints in this HTTP API that the Go toolchain will use to figure out what version to download and then download the version. And it's all done over GET requests, HTTP GET requests. So what we see is that this is a brand new way to fetch Go code. If you remember before, where we had Go Get, and we had other tools like Glide and Dep and GoDeps, and I think Go Imports maybe did some stuff around that too. those all used VCS interfaces. So most of the time it was Git, sometimes it was Mercurial. I think there were maybe some other ones as well too. And so when you ran a go get or a dep ensure or something like that, that would just fork exec into a Git clone or whatever. And that would mean pulling down the entire source tree, history and all. And then that tool would configure the cloned code to use the right tag or the right SHA or whatever. Right, so this is different. This doesn't have anything to do with version control systems in the front end. It's just code. Okay. And so we're using HTTP. Not only is that a brand new way to do stuff with Go code, it's also a very, very easy, obvious way to do downloads, right? So we've got this concept, for example, of a CDN. Downloads are done billions and billions of times a day over a browser, as everyone knows. HTTP is the lingua franca of the web. I'm not really saying anything new here, but what I am saying is now that we have HTTP as a way to download Go code, we can apply internet technologies to the Go code download protocol. And we're going to apply a CDN. So I took a little passage out of the Wikipedia article here for a CDN. And basically what the whole article is saying is there are these inner workings and technical details of the CDNs, of most CDNs. But they all basically boil down to making it really easy and fast for anyone to download stuff. Video, binaries, whatever, music, whatever else, right? So they're really optimized for serving stuff most of the time over HTTP to people who come to your site or come to your API or whatever else. Okay, but we run into this problem. Okay, so HTTP is great. You can apply CDNs to HTTP, but the Git protocol, and specifically Git push, is not a CDN, and it's not HTTP. And especially if we go to GitHub, if we take GitHub as an example, or Azure repos, or Google Cloud repos, or GitLab, or whatever else, none of that stuff is what we call an origin server for a CDN. Okay? An origin server is where the content comes from, right? So if we put a CDN in front of GitHub, that's great, because then the code comes out of GitHub once and gets put into the CDN storage and everything is good. But right now, the kind of the state of the art before Go 1.11 and before Athens is that we pull stuff directly out of GitHub. And that's a problem for two reasons. First reason is that the Git protocol is not really meant for doing heavy read, heavy download operations. It's meant to do version tracking, and it's meant to do collaborative development. Those are very different things. And the second thing is you can change the content in GitHub really easily, right? Git push -f is a way to change a tag. You can delete a tag. You can delete a branch. You can delete or change any commit SHA that you want, right? So it's really not reliable as a source, a global source for dependency management. And if you look, we can see that in the past, this has been a problem. Most recently, the most recent sort of large-scale issue that came about around this, that I know of at least, is with Go bin data, Go-bin data. Okay, so it was under someone's repo on like a Monday, I think, or maybe a Tuesday, and it got deleted that night. I think whoever owned that repo might have deleted it on accident, or who knows. And someone else saw that. They happened to have it cached on their local machine. They created a new repo, called it Go bin data, and then said, okay, well, I'm going to change my dependency file to point to my repo. And the next day, I think Wednesday, word got out that the old one is gone. People's builds started failing and so forth. And once word got out that the old one was gone, it also got out that there was a new one. So everyone had to switch their build scripts and their build dependency files over to using the new one. Okay, so this is a problem. This is a real life problem. And that wasn't the only time that this kind of thing happened. So clearly, we need the solution. We need to do something better than just storing everything and fetching it directly out of GitHub. Storing it is great. GitHub is a great tool. We all know that. GitLab is the same thing. Bitbucket, same thing. Those are all really great code hosting services, but they're not good dependency hosting services. And that's what we need to fix. Okay. And as I said, I kind of alluded to this. We've always been sort of on the brink of something bad happening with our dependencies. It's been everything from the Go bin data case to GitHub having minor outages to just non-deterministic builds for whatever reason due to entropy, right? If someone accidentally changes their repo or accidentally deletes a branch or a tag that they thought no one else was using in the Go community, to even bigger things like Google Code. There were dependencies in Google Code that people used in their Go programs. And then one day, actually, we knew Google Code was going to shut down for a long time, but one day it actually did. And then all those dependencies were just gone. No one had access to them anymore. And of course, luckily, it's the big, huge Go community that kept caches everywhere on their local machines and in their CI disks and so forth. So people recovered and the community did what it does best and reshared the code back up to GitHub in that case. But all of these sort of small isolated incidents that we recovered from, they all add up to this big sort of prediction or this big issue that shows that, hey, something could go wrong and it could cost us a lot of time for debugging and recovering, and that's time that just we get taken away from us that we could otherwise be using to build better programs and so forth. And that is what Athens is trying to do. So Athens is trying to bridge the gap between having Git, GitHub or GitLab or Azure repos or Bitbucket or whatever, having all those version control systems and merging that with the concept of a CDN. And I'll show how Athens does that. But basically, the way to think about it at the highest level is we're trying to get a database of source code and expose it via a CDN to make it globally accessible. Okay. And before we go into the details there, I just want to make this quick note that the new workflow that everyone's used to, the new workflow is going to be pretty much the same as what everyone's used to. There are two new commands. We do a go mod init that creates our new sort of local environment for the Go project. And then we set this environment variable once. We do both of those once in our shell. And then after that, we're off to the races. We do our normal Go gets, we do Go builds, we do Go runs, and everything else. And it's easy, right? We don't have to learn new tools. And actually, we don't have to use any other tools outside of the Go toolchain either. So no strict need to use dep or glide or so forth. But a quick note on those aren't going to go away. You can still use them. But this is a new option. You can use go get, go build, and so on. So let's go into a demo. Let's see this workflow in action using Athens as the backend. Athens is the database, it's the global CDN, and it's also the mechanism to load code from GitHub or GitLab or whatever into the database and expose it over the global CDN. All right. So I'm going to head over to this repository. This is a public repo, and there will be a link to it in the slides and the show notes. So this repository is basically a server using the Echo framework. It's an HTTP server using the Echo framework. It's pretty much copied directly from the Echo server GitHub page. You can kind of look at it here. I just made this little change to say hi to the PDX Gopher meetup group. But other than that, it's exactly the same thing. Nothing too special there. But the point of this demo really isn't the app, it's to show that the app's dependencies can be satisfied from Athens and not from GitHub. Okay, so this is kind of explaining what I just talked about. I'm actually going to go and clone this repository real quick. And I'm going to clone it onto my desktop. Clear the screen. I'll make this a little bigger so folks can see. We're going to do the git clone. Okay. Let's go into the directory here. Okay. So we cloned it. And just as a quick note, it's not in our Go path. So our Go path is users a/go code, and I am on the desktop. So this is strictly outside of the Go path. And that's a big point here. That's a nice thing to have, but it's also a big point is that now that we have modules, we don't use the global Go path by default. We have a feature that we can use to decide not to use the global Go path to resolve our dependencies. Okay. So if we do, if we open this up in VS Code, just gonna do that real quick. So if we open it up, we go to main.go, and this stuff, oh boy, we got a lot of VS Code updates going on here. And this stuff is all fine, right? Close that down. So this is just regular code. It's the same code we saw in GitHub. And my syntax highlighting in VS Code looks like it's still kind of spinning up. But basically this is what you see after the Go code server starts up and syntax highlighting kicks in. So you don't have those dependencies. Okay. So I'm going to skip over this. I already talked about the Go path. And I'm going to set up my environment. These were those two commands that we saw in that workflow slide. You got to set an environment variable here, and you have to do an export here. So this environment variable is going to turn on the Go module system. In Go 1.11, they're turned off by default, and you have to have code in the Go path. So this, I'm going to copy, and I'm going to paste. Okay, so that's one. And the second one is the Go proxy environment variable. Okay, so I'm going to point the Go module system to this website, or excuse me, this API server. And this is a real life Athens server running on Azure for web apps. Okay, so I put a quick note down here. This is just like, it's there for experimentation. There are documentation on how to set up your own, but this one's great for kind of playing around and experimenting. But please don't rely on it in your CI or CD or anything sort of production facing, because this might disappear. Okay, so I'm going to copy and paste this. Not GitHub desktop. Paste it in here. Okay, so we've got our environment set up for Go modules. Now, the next thing I mentioned that we turned on Go modules here, so we are not going to be resolving the dependencies from our Go path. But we may resolve them from this new cache that the Go module system keeps, and that is under Go path /pkg/mod. Okay, so that's like a global cache on your machine, similar to the Go path in that it has all the code. But different because it has the code version, and it can be used from any directory that has a Go project on your machine. So what we're going to do is, just for good measure, we're going to delete both. We're going to delete both the Go path version of Echo and the PKG mod global path, a global cache for the Go module system. Okay, so the first one here, I think this either doesn't exist or it may fail, but let's see. Yep, this does exist, but it's failing because it is a read-only directory. And the Go module system does that on purpose so that you can't mess with it under the hood. But I'm going to mess with it under the hood by blowing away the entire cache. Okay, so that's gone. That means that every go get we do in the Go module system, for example, inside of this directory, that whether it goes to Athens or whether it goes directly out to the VCS, it's going to have a cache miss. So there's going to be no code in the pkg mod directory, and Go modules is going to have to go out and find that code. So since we have set Go proxy to that, we know that the Go module system, we know that it's always going to go check for the code here. And actually, if it can't find it here, then the build will fail. And that's important because now we're funneling all of our dependency management through Athens, which is nice because Athens handles that for us. Okay, so let's also delete the lab stack echo in our Go path. And I'm not even sure if I have that. I do not. Okay, so that's done already. Okay, now let's do a Go build. Let's see what happens if we do the Go build. So again, this is going to build a web server, and the web server has two dependencies, echo and echo middleware. But it's got a little bit more than that, of course, because echo and echo middleware have their own dependencies, and those dependencies have their own, and so on. Those are called transitive dependencies. Okay, so we're going to do a Go build. Clear the screen here. And you see here, we've got a bunch of finding, and then we've got a bunch of downloading. So what's happening here is the Go build tool is going in here and saying, oh, okay, lab stack echo. Let me check in my global cache. That's the one that's under pkg/mod under the Go path. And it did that here. Okay, so it looked for it and said, oh, okay, not there. So I gotta go download it. And it did the same thing with some of the echo dependencies, buffer pool, crypto, Gammon, and so forth, right? So eventually all that was done. It got everything it needed. And if we look in the Go mod, this is absolutely everything it needs. Okay, so we've like Java Web Token support. I don't remember what Gammon is. This is for console output. This is fast buffer tools, templating, crypto. I don't remember what TTY is. I think it's for some console output. Okay? And then we've got a go.sum file, which is basically a lock file. So this has exact hashes for every single package that's in the go.mod. And these are for cryptography, right? You can cryptographically verify a package that you download later after you've got this go.sum file. Okay? So just to make sure, we're gonna run the server. We've got our amazing binary name, and there it is. And then just for good kicks, let's do a curl against it. It's port 1323. Yep, and that's the app that we expected. Hey, PDX Gophers. Okay? All right, so that on the cover of things, it kind of looked fairly simple. We basically use the same tools as we always have, except we set that one environment variable. So let's go back to the slides and see why this is real, why this works, and what the benefits are. Okay? So the key thing was setting the Go proxy environment variable. If we didn't do that, then even the new Go modules go get command would go out to the VCS. And then we're still back with those same problems where GitHub is our CDN. Okay? And that is all good if we do one of two things. If we either do a go get once and we just keep our go path cache, keep our go path as a cache, and store that somewhere central that all of our development machines can use. The other one is we could check in vendor. And both of those techniques are totally reasonable, right? But eventually we do have this case where someone else might do a new go get for a new dependency, and they'll pull down the right stuff, and then it will work on their machine. Their build would succeed, and the code that got built into their binary is exactly what they expected. But then 5 minutes later, someone else pulls down the code and they do the go get as well. And they might get completely different code, or it might fail because maybe the code is gone. And you can repeat that and you can say, okay, well, maybe the code is a year old. And then someone comes in a year later and does a go get. Well, now the code might be completely different, or it might be gone, right? As time goes on, entropy builds, and the more likely it is that something will break or change. And that's why we get this sort of, it works on my machine issue when we run into a VCS as CDN type of situation here. Okay. The second piece that's really nice here is speed, right? So Athens, of course, is not a Git server or a Mercurial server. It's just an HTTP server. So the way that it works is basically like a cache that doesn't have an expiration date. So if you do a go get on LabStack Echo, for example, it's going to look in its storage, in its database. It's going to return LabStack Echo right from the database. If it's not in the database, on the back end, it will go out to GitHub, grab LabStack Echo, and save it in the database forever. Okay? And that means forever across all go gets across the entire globe. So you do one go get, and then from that point on, no more GitHub interaction. And it's immutable in the database, so that even if someone deletes it off of GitHub, that's okay, because it will still be inside of Athens. So that's the first part about speed. The second part about speed is something I alluded to before, earlier in this presentation. And that is that the code, the dependencies that we're downloading are just from a REST API. And that REST API basically has two small metadata files, maybe a kilobyte or so each, and then a zip file with the code. And it's just the code. It's not all the VCS metadata, not the Git history or the Mercurial tag list or anything like that. And that makes not that big of a difference for a small project like Echo. Echo is a couple years old, so it's got some pretty decent amount of history, but it's also not that big of a tree because there's not a lot of source files. So really the difference between doing a curl to download a zip file with Echo in it versus doing a git clone is not that much different over like a pretty good internet connection and a pretty powerful machine. It's not that big a deal. So if you're doing it in your CI environment in the cloud and you're using go get for LabStack Echo, it's not going to make that much of a difference. But scale that up now. Scale that up to using LabStack Echo and 20 other dependencies, and have each of those dependencies have 20 of their own dependencies. And now you've got this combinatorial explosion. You have this dependency graph that's really deep. You've got tons of dependencies, and now you've got tons of different VCS trees, Git trees or Mercurial or whatever, and they're all doing Git clones off of various different Git servers. You might have an internal GitLab server that you're just doing a bunch of Git clones off of, and you might have GitHub out there, and you might have public GitLab and Azure repos and whatever else. And you rely now on all those different servers to be working fast and so on and so forth. That's federation, right? That's one of the costs of federation. But also, now, if you scale that out to your entire development team or even bigger to the entire Go community, that's tens of thousands or maybe even millions of downloads for that package a day, or maybe even more than that. Okay? And so that is unnecessary data to be downloading, right? The fastest way to do this would be to package up the code in a zip file, store the zip file in some fast storage, and serve it out of fast storage. And that's what Athens does. That's what any proxy should do over an HTTP protocol, including a CDN. Okay, so that brings us to now. We showed Athens in action. We showed some of sort of the specific benefits of Athens. So where is Athens right now? What's going on with the project? Well, you can see we've deployed Athens to the internet. We've deployed it to an Azure Web Apps instance. And it's containerized, so it can be deployed anywhere else. We haven't really gotten to it, but You can deploy it to Kubernetes or Google App Engine's container environment or Amazon ECS or Docker Swarm or HashiCorp Nomad, or the list goes on and on and on, right? You could even deploy it internally, and I'll get to that in a second. All right, so it's deployed. It's currently in Alpha 2, and we're going to get to beta pretty soon now. And once we get to beta, we'll have some more guarantees on what people can do with the software themselves. And we will continue also to have this sort of testing experimental server for folks to mess around with. Eventually, we will get sort of a beta of that server up as well, but that will be separate from when we release sort of the beta of the code. So hopefully that makes sense why we're splitting those two things up. So I wanted to cover a couple use cases as well. The first one I kind of just mentioned. People are running Athens inside of their own companies. And I call this inside of the firewall because there are some use cases at companies that they just don't have access to the internet from inside of their corporate environment. And Athens works there, right? It's a software that's completely open source, and we've put a lot of effort into making sure that it is easy to install and configure on your machine. Okay, so you could install it on a machine inside of your own data center or your own private cloud, and you can point it to your own internal private code hosting repository. And it can serve your private code. Okay, so you still get the same benefits of sort of a public internet-wide CDN, but you get them inside of your own organization for your own code. So it's the same concept applies of build determinism and speed. So in the build determinism department, if someone checks in a new version of your internal library, it'll get served by Athens, and Athens will store it in its immutable database of code. So if it gets lost or something happens to the source code, Athens still has it, and people's builds still succeed. The second piece is as your code base grows bigger and gets older, and as you add more developers on, your trees get larger and larger, right? Even if you've got 5 files in your code base, but you've got a history that's 50 years old in terms of man hours, and maybe you used to have 5 million files, but you pared it down. It doesn't matter if you have 5 files with Git. If you do the Git clone, you still have to download all of that history. In Athens, that's great for Git, for version control and development, but Athens cuts all that history out, which is very nice when you're trying to just download the most current version of the code. So another great use case for doing stuff inside of the firewall is that Athens can be configured to get code from an upstream. And the upstream can either be GitHub or a public VCS. It could be another Athens, either inside or outside of your firewall. Or it could just be dev null, and Athens could 404 and say, nope, this dependency does not exist. And that, we have a feature in Athens that can force Athens to say that this dependency does not exist, even if it does. And that's called an include and exclude list. So in the exclude list case, maybe your CTO or some of your engineers might find, let's say they're a security team and they find an exploit in one of the libraries that you use. Well, they can go into Athens and put that library on the exclude list so that no one can download it again. Okay? And the include list is the list that you say, these are my private repositories and these are my private modules. And Athens will ensure that it will never go upstream to check if one of those modules exists. It will never go outside of your firewall or try to hit the public internet, as we say, for any of those private modules. So that gives you the benefit of sort of all the Athens CDN module HTTP protocol things, but keeping them inside of your own environment. The other big use case that we've seen is actually what we do right now with that public Athens proxy that I just showed in action. And that is with mirrors. Okay? Anyone can run this proxy, just like anyone can run it internal to their company. It's just as easy to run it externally on the internet. Right? So you can run one yourself. You can spin up an Azure VM, or you can put this onto Google App Engine, or onto Amazon or anywhere else. You can run it. It's a one-liner just about to run. And you can mirror code from your own VCS, from your own projects. You can mirror code from another Athens proxy. You can mirror code from a CDN. It doesn't matter. As long as you can mirror it from a VCS or the Go HTTP download protocol for modules, you can set up your own mirror using Athens. And that brings me to my last point. That download protocol that I showed in action, I showed it specified in a slide, and then I showed it in action in the demo. We call that the lingua franca of Go modules anywhere. Right? Just like VCS is sort of the lingua franca of Go Get, and it's obviously the lingua franca of most development teams using the Git command line tool, for example. The download protocol is the way that Go modules are sent around the internet. So anyone can run a mirror, anyone can point it at any other mirror or any other server, and they can speak to each other using that same API. It's a simple and standard API, which makes this a very powerful network of mirrors. Okay, and I kind of alluded to this before, but there's plenty more to come in this realm. Right, so Athens is growing fast. There's a big community. The community keeps growing as well. There's new features to come, and there's going to be new announcements to come as well. So expect more from the project, and expect more of these screencasts as well, sort of explaining how things work. And the last piece that I'd like to say is everything that I did in that demo is easily done by you too. Really, all you have to do is set your Go proxy environment variable to this Microsoft goproxy.azurewebsites.net. Make sure to put HTTPS in front of it there, and set that environment variable however you would in your shell. It's a little different in PowerShell, about the same for Bash and ZSH and so forth. And after you set that, assuming you have the module system turned on, of course, and you can go back to the demo and see how that's done. You can always run go get and go build and go mod init and all that nice new module-y stuff. And it's really nice to see that stuff in action. And then that piece down there is important in bold. I mentioned this before, and I'll just repeat it once. This is experimental, this URL. So right now it's got an Athens running. It's had an Athens running there for the last couple weeks, but it's got bugs. It's actually not even the most up-to-date version of Athens right now. So we'll be doing upgrades. It might go offline. We might change the URL. So just be aware of that when you're using this stuff, that it's probably not production ready at the moment. And then finally, I'd love for folks to get involved. So if you're watching this, a great place to start would either be our documentation site, docs.gomods.io, or the actual GitHub page for Athens. This is where all the code is written and all the community lives and does its work, etc. So that's github.com/gomods/Athens. And then also importantly, we all talk and hang out on Slack. So if you're on the Gophers Slack, come check us out, #Athens. If you're not on the Gophers Slack, just do a search for Gophers Slack invite. So these two words and then invite. And it'll take you to a page where you just put in your information and you get added to the Slack channel immediately. Okay? So absolutely everyone is welcome to get involved, regardless of experience level, regardless of background, regardless of everything. We would just love to have your perspective in on our project. And if you don't know where to start, just come join us in the Slack. Say hi. We'll say hi back. We're very, very friendly. And we've got folks spread across a few different time zones. So if you think it's too late or too early or whatever, it's probably not. So yeah, we just love to hear from you. Come say hi. Come try us out. and we will really look forward to seeing you. All right, thanks everybody. There's my Twitter again, and that is going to be in the show notes as well, but that's the short link to get to that repository with all the demos in it. All right, so with that, I will say goodbye. Take care, everybody, and enjoy Athens.